What's going on, guys? Power Standard 1 review here for Module 1, Topic 3, Linear Regression. So, linear regression was actually our first taste of linear functions. Now, this was way back in Module 1, Topic 3, so a couple units ago now. But I think these ideas, this y equals mx plus b, the slope and the y-intercept, or the slope and the initial value, these ideas have been reinforced the past couple chapters, so I actually think that this should be a lot easier going back to it now. Alright, so linear regression. Let's look at number 1. The table shows the amount Andre earned as a waiter. The money in dollars is the total amount he earned. So here we have a situation. Let's see, if Andre works 0 hours, well, he hasn't worked anything, so he hasn't gotten any money. But after the first hour, he actually got a tip of $16. Alright, second hour, 35, and so on. So we can actually see that this actually will not be a perfectly linear pattern, considering in that first hour he made 16, but in the second hour it was 35. So if this was perfectly linear, it would have been 16 plus 16, which would have been 32. But we see that we actually don't have a straight line here. So if I actually were to make a scatter plot, let's say with the time and the money over here, well, the first value was 0, 0, and then we have some random scatter. So the situation might look something like this, not perfect. Now the problem actually goes ahead and gives you a linear regression equation. So this might be where you guys don't really remember, I imagine, what linear regression is. It's been a while. But what linear regression is you have a situation, in this case Andre, and how much money he's worked and how much time he's worked and how much money he's made. And what a regression equation is this line of best fit, this linear function that tries to best model the data. So if I look at my scatter plot over here, which shows how much time he's worked and how much money he's earned, if I were to estimate where that line of best fit is, it's this line where it's kind of in the middle of all your values. Alright, and they actually give you what that linear regression equation is. It's y equals 14.36x plus 2.25. So the question asks, predict the amount earned after 12 hours. Now, if we look at the table, we obviously see that the table doesn't go all the way up to 12. It ends at 7. Now, when it says predict, that's what this regression equation is used for. The whole power of a linear regression equation is to predict things, because the actual values are given to you in the table, but the prediction is what the equation is. So show your work and explain your answer in context of the problem. Predict after 12 hours, well, that's just a simple plug into your equation, and let's see what values we get. 14.36, now I'm going to substitute a 12, plus 2.25, and whatever value this gives you will be the predicted amount after 12 hours. So give me 1 second here while I type this in my calculator. 14.36 times 12 plus 2.25, and we get 174.57. Okay, so we have our work shown. We did that. And explain your answer in the context of the problem. Well, what does this number mean? Well, that would be the amount that Andre earns after 12 hours, right? That's why we plugged in the 12. Now, it is important that because we are actually predicting, that we mention somewhere that this is a predicted amount, not the actual amount. So we can say something along the lines of, according to the model, that way it's said that we're actually trying to predict. According to the model, Andre will earn $174.57 after working 12 hours. Alright, that's really it for this problem. Just asks you to substitute a value and then explain your answer in the context of the problem. All right, so let's look at number 2 now. Number 2 is a little more difficult, but still deals with some linear regression stuff. So the table shows the decrease in the amount of chicken feed in a farmer's barn over a 7-month period. So chicken feed is what chickens are fed. Now obviously as the months are going by, there's less and less and less because the chickens are eating it. So in March we start with 950, so on and so on. All right, the linear regression equation for the situation is represented by the following equation. So they actually go ahead and give you this equation. Letter A, interpret the regression equation in terms of the problem situation. Interpret. All right, you guys have seen that word a lot in this course, and I imagine also a lot in your English courses. So interpret means we have to explain. Explain what this equation actually means. Well, by looking at this equation, there's only 2 things we can really talk about. That's this negative 94 and this 1210. Well, this negative 94, you guys know that any number that's next to the x in a linear function, that's really what our slope is. And I like to think of our slope as a fraction. So in this case, it's just negative 94 over 1. So let's explain what that actually means. So in this situation, we can see that the months are steadily increasing, just 1 month, right, from March to April to May to June, while the pounds are decreasing by a much bigger value, not just 1. It looks like it's decreasing by almost 100, right? It goes from 950 to 850 about, then to 790, so on. So what does this slope mean? Well, in this situation, for every 1 month, we can tell that the months are increasing by 1. For every 1 month, the amount of chicken feed decreases. It's important to talk about increasing or decreasing when you're talking about the slope. Decreases by 94, I can say pounds. All right, so that's the slope. All right, for every 1 month, the amount of chicken feed decreases by 94 pounds. But now we can also talk about this value right here. What does this 1210 mean? Well, in a linear function that's given to you in y equals mx plus b form, we have the slope, and then we have this other number, which is our initial value, or our y-intercept. So in this case, we have a 0, 1210, if we were actually to plot this on a coordinate plane. What does this 0 mean? And what does this 1210 mean? Well, this means month 0, which if you look up here, March is the 3rd month, April is the 4th month, May is the 5th month. So it's kind of weird because we're talking about months, but let's go back a little bit. See if you can think of what month 2 would be. So what's the month right before March? That's February. And then 1 is right before February, which is January. And right before 1 is 0. Well, this is kind of a little weird because you have to actually go back into the previous year. So before January actually is December. So when it says 0, we're actually talking about December of the previous year. And 1210, well, this is how much chicken feed they had. All right? So we can say that in December of the previous year, the amount of chicken feed is 1,210 pounds. All right. Now, since it is a regression equation and the problem itself said that this is a regression equation, it is important to note that this is just a prediction, right? It is not that exactly for every 1 month the chicken feed decreases by 94 pounds. it is a prediction. And the same thing in December of the previous year, when it says that it was 1,210 pounds, that is a prediction. Just understand that these are not actual values. The only actual values that we have in this problem are what's given to you in the table. Now, it's important to understand the difference there between actual values and predicted values, because letter B deals with both. So letter B, let's pick a different color here. Let's go with green. According to the regression equation, the predicted amount of chicken feed in July is 552. Let me write that over here. So predicted for July, we have 552. Well, if I look at the table, that's not what actually happened. The amount of chicken feed that they had in July, so like the actual July, was 624. So according to the regression equation, the predicted amount is 552, but what they actually had in July was 624. So the rest of the problem says to calculate the residual, which is actual minus predicted, for July, and interpret it in terms of the problem situation. Okay, so what it's really asking you to do is just compare these two numbers. So the predicted amount was 552. What actually happened was 624. Now the residual will give you a nice number which you can use to describe how off the prediction was. So this formula right here, where we have actual minus predicted, what was the actual amount in July? There were 624 pounds left of chicken feed in July, where the equation predicted 552. All right, well, if I actually calculate this, 624 minus 552, we get 72. Now, this is what is called our residual value. Residual is just another nice fancy term to describe how off your estimate was. So 624 minus 552, we get a positive 72. Now, what does this mean? This is where this interpreting comes in. What does this mean in this specific scenario? It means that the amount of chicken feed in July is actually 72 pounds more than predicted. And I know it's more because we got a positive number. And even just comparing these two values, the actual amount was 72 more than the lower amount for the predicted. Alright guys, you guys can try the next problem. Thanks for watching the video. If you have any questions, feel free to ask your teacher. Thanks.